So I share my screen, and everybody who joins, they would need to catch up. So let me know if you see my screen. What you should probably do, so this is where we stopped yesterday. What we should probably do is to run this initial cell here, which had this setup. So the setup, all the NumPy and Pandas and Matplotlib and all that kind of things, it would make sense if you guys run it. Igor, hey, morning. He's joining. Morning.
Morning.
Morning. We had a short introduction talk. So now we went back into business. So if you please can open the supervised learning collaboratory as what we left out yesterday. And you could rerun the initial setup cell, right? This cell, setup cell. It should show you that it uses TensorFlow version 1 and so on and so forth. Yada, yada, yada. What happens? Yeah.
I'm sorry. I will be at my computer in 20 minutes, so I am in review here, but not with my computer. In 20 minutes, I will open and be with you 100%.
Okay. I'm not sure you will be able to catch up after 20 minutes, but let's hope for that. So let's run this. So this is what we have done yesterday together with you. We have downloaded the New York City Taxi prediction challenge data. So you guys should do it again today because your collaborator didn't save files since yesterday. So you need to redo it. So you need to re-enter the password. I just did it before the call, so I don't have that message and I don't really need to click on the link, but you guys will definitely need. So you need to rerun these things and you should get the file as well. All right. Yeah, so I have it in my virtual environment somewhere in the middle of the mountain in the California. There is a virtual machine with my name, and this virtual machine on its drive has this New York City _data.zip, which is the file that contains data for this Kaggle competition, right? So I unzip this file and I look at the insights of this file. This is what we have done yesterday. We looked at the train _2 million, test CSV, sorry, model.pickle, sample submission. So these are the files that we will be looking at during today. And then this tricky Kaggle thingies, right? So this is my username, this is my key, but you guys should have your own JSON file with a Kaggle.json that has this username and key that you need to copy paste into these lines. So you need to rerun this and get going. So I will try it again. I'll see probably the same mistake as yesterday. All right, so it says cannot create regular file. So I just go on to the next cell. I've run it. I get some errors again, something from input-output errors. And then I go back and I rerun the CP line and it works. Magic. It's a magic. I don't know how it works, but it works. And then I run again this. Go ahead.
Today it worked. It seems from the beginning for me somehow.
Oh, okay. And it never works from the beginning for me, but if you do this trick, it's somehow compelling. It somehow makes it make its way. I don't know how, but it just makes its way. So you guys, so let me show you this. This is a New York City Taxi Fare Prediction Challenge. This is the homepage of the challenge. And you need to register for the challenge. So you need to say, I want to participate. And since I have it, I don't have the button here. but you should guys have a button here. I think when you click on the late submission, you will get this dialog that will pop out and it will say, hey, are you agreeing with the terms? And you're like, yeah, sure, I'm agreeing with the terms. And then you will be part of the competition. Okay, you need to do it because otherwise your submissions will not be accepted by the competition server. And that is not something this is something we want to avoid. So you need to accept the New York City taxi prediction rules. Got
And
you,
this
right?
link, yes, you sent in
Slack. Yeah, in Slack.
In Slack, yeah.
Yeah, the last one in Slack.
So it will be late submission, yeah, for us option.
Yeah. So if you click on the late submission, I got like, all right. So so if you click on the late submission, it should say step 1, step 2, and stuff like this. If you click on my submissions, you should see an empty page. While I have like tons of stuff here. All right, you should see an empty page. It should say, well, your most recent submission, none, and that kind of things. Okay.
Yeah, currently I see it's empty, but I pushed late submission, but I don't see any. This is okay, now I see the step 1, upload submission file. Okay, this.
So the thing is, you don't really need this.
Okay.
What we're going to do is we are going to push the submissions from our collaboratory. So what we have done with this weird steps here with the JSON file and that kind of stuff, we have just set up the API, right? Something to talk to Kaggle server from the collaboratory. So what is going to happen is that we are going to just run the code and we will submit the file from our virtual machine. We will send the file to the Kaggle, and they will basically evaluate the internals of this file on their server, right? So they will tell us how good we did with respect to their server. So to test this approach, you can run this Kaggle competition submit line, and it should say something like, I uploaded my file, here's the file. So this line actually is saying Kaggle competitions submit and the competition name, and then it says, hey, send a file name sample submission.csv, and we just open it up. So this was the sample submission.csv, all right? And so when you send it, it should say successfully submitted to New York City taxi fare prediction. And I'll tell you in a moment what exactly is inside the sample submission file. We will see what is inside sample submission file. But you need to make sure that this line is there. And if you go to your submissions, so if I go to my submissions and I update the page, I can see that my last submission is a few seconds ago. All right. And you guys should see it on the page. It should say a few seconds ago. Simeon, is it there?
Yeah, so I'm on my way because I by mistake I closed the notebook, the collab notebook. That's okay. I'm restarting everything, but yes, I registered on the Kaggle and I found this.
So if you're starting, Igor, if you're listening to us, then basically what we need to do is just to run a setup cell here in the very beginning. So this is the setup cell that we need to run. And then we just need to start with the New York City, data set here. We need to upload the data set with a link, copy paste the code, get the zip file. So we should run all the cells from here. So from this cell until the end of the Kaggle cells, okay? All right, so Simon, tell us when you're done.
Okay.
Yeah, Igor, if you're close to computer, please memorize the steps. So you need to run the steps cells from the New York City. Oops, I did something wrong. From the New York City taxi data set down there until the last Kaggle cell here.
Yeah, clear.
Yeah, it should be quite simple. And then if you go to your New York City taxi fare prediction homepage, you should see that your last submission was a few seconds ago. That would just verify that you have done everything correctly and everything works. So Oleg, does it work for you?
Okay, let's see.
So, sorry, was muted. You mean that we need to execute this now, submission code?
Yes. Execute the submission code here and see that it says that successfully submitted to New York City taxi fare prediction. And then if you go to your submission, into your My Submissions page, you should see, and I can send it to Slack. So this is another link to Slack, My Submissions at Kaggle NYC. So this is a link for My Submissions. So this is where you should see submitted a few seconds ago, or a few minutes if you have done it some time ago.
Let me check. Yes, I have it.
Simeon, how are you?
Yeah, fine.
Good. Now, ladies and gentlemen, let's go to something called leaderboard. All right. So what is the score of our submission? This is a score. So this is how good the submission was. So just to give you a couple of, just to give you a context, what the hell are we doing here? So this New York City taxi fare prediction is basically it's trying to do the same stuff as what we have done yesterday in the lecture when we were trying to predict the price of the ride, right? So we are trying to predict how many dollars a person would pay based on the information that is known about their trip, about their taxi trip. Basically we are solving regression problem. What do you think is the score? So yesterday, what was the score? What was the error function we have been calculating all over the lecture? What was the error function name when we built the decision trees?
Distance, square distance.
Not exactly distance. So it was a distance.
You mean what's value or what's
the name of the error that we have been calculating yesterday to build, for example, decision tree?
Mean square.
Mean squared. MSC.
Error estimate.
Mean squared there.
Yeah.
Yes. So this score here, I think, as far as I remember, is RMSE. So it's a root mean square there, right? So if we go to the, I think it was overview. I'm not sure. Yeah, it's RMSE, right? Mm-hmm. So RMSE is a root mean square error. So this is whatever we have calculated yesterday, plus there is a square root on top of that. So now what I want to ask you is, can you go to the leaderboard? So this is a leaderboard here, and look for a place that we, with you, would occupy in the table of ranks of this competition, provided that we would have a score of 9.4. Where would we be? What would be the place number if we would have a score submission of 9.4?
Wait a moment. Okay, it's somewhere 9.4. This is somewhere 1,400.
Yeah, it's like the bottom of the table, right? It's the bottom of the table because there are 1,400 teams on the on the competition, since the competition is basically over, the competition is over, we would be somewhere here, about 1,400 place, which is not very nice. So, okay, one thing here is that since the competition is over, our submission does not show up. So we don't have a separate line for our submissions, okay? We don't have a separate line. Otherwise, we would show up in this table. So we would be somewhere in this table. But since we aren't, since the competition is over, we are not in this table. But we can always hypothesize where would we be provided the competition would still be running, okay? And currently we are not, this is not very good. 1,400 out of 1,483 is not very good. So let's try to improve our position with respect to other people, and we shall see how we can do it. So let's get back to the collaboratory. So sample submission is something that Kaggle competition provides by default. So you don't really need to do any analysis. You can submit your sample submission and that would be it. But since we are trained data scientists, we can actually do some analysis, right? So let's do some analysis. So the first thing we do, we actually, you remember we have downloaded this train_2 million. This is basically a data, right? This is our data that we can use. Test.csv is something that Kaggle uses to evaluate our predictions. So we don't have labels for the test CSV. And I'll basically show you in a second. So we read in train_2 million, and we read in only 1 million rows, okay? Only 1 million. Why do you think we read only 1 million rows? Simon, why do you think we read only 1 million out of 2 million?
To keep some. So if I understood correctly, we have separate sample for training, for test, correct?
Yes, yes.
So in this case, we do it to use another million for just to economize, to speed up the process.
Yeah, exactly. To keep the sanity. You know what the sanity? Just to be sane, not to wait for an hour. So let's just read in 1 million. You can use this beautiful underscores if you like. This is a stylish Python. That's a stylish Python. So we read in the train, and here you see this one is a weird % time. This is basically a way to measure the cell running time. So if you ever want to know how long your cell in collaboratory runs, you just type % time, and this is what it will do, right? So we just read in the train data set, 1 million rows, and it took us all together 1.28 seconds. Okay, quite quick. Now, and by the way, there are plenty of ways to read in that CSV file in Python. This is one of the fastest by far. Now let's look at the data. Let's see what is inside the data. Yeah, so we have price of the trip. Let's consider it to be dollars since we are in New York, so it must be dollars. We have a pickup daytime. So this is where the driver met the customer. This is where the customer got into the car. We have a latitude, a longitude and latitude of the pickup. So these are the coordinates of the pickup. Oh, we have 2 Igors. Igor, you have 2 Igors. They multiply now. This is to increase the bandwidth, I guess. Anyway, yay! Just 1 Igor left in the conversation. Great. Igor, are you with the computer now?
Yep, right now, yes.
Great. Do you remember what should you do?
Yeah. Exactly.
Go ahead, because we will be like moving slowly to try to catch you up. Okay.
Thanks. Thank you.
Go ahead and ask us questions as soon as you feel like there is something to ask. Okay.
Okay.
We also have a drop-off longitude and drop-off latitude, right? So these are the locations where we drop the passenger. And then we also have a passenger count. So how many people did we pick up? This line here, train.types, is saying, what are the types of different features that we have here? So fair amount is obviously a float. You know what's float, right? This is a continuous valued stuff. Daytime is obviously a daytime, makes sense. And passenger count makes sense to me, is an integer, cannot really be a floating type unless you're a mafia person and you're transporting parts of people, right? So it's definitely not something we wish for. Let's describe the data by running train.describe. And here, you guys, I ask you to look inside this describe function. It says how many rows there are in the feature. What does that mean? What's the standard deviation? What's the smallest and what's the highest values? And let me know if you see something that is odd, something that doesn't make much sense. Tell me if there is anything that makes no sense to you. And what is it? So there are at least 6 things that shouldn't make sense. You know, this is like a children's book. Find mismatches. So this is your way to find mismatches with the common sense. So what are the mismatches with the common sense? Name them. Name them. What are the mismatches?
So what I see, let's start from the count. Drop-off latitude attitude is not equal to pickup. It means that some 10 people started the trip but didn't finish it.
Yeah, that's weird, right? That's really weird. I would check it out. Where did they end up, right? What's the longitude and latitude of their drop-off location?
Yeah.
All right, that's good. So we have 999,990 times we drop people off, and when we have 1 million people, we took in the car, right? So the natural question asked, so where are the 10 people? Where did you get 10 people, right? Oleg, anything else that comes and like catches your eye? What is that thing that doesn't make right?
The minimum value of fair amount, it's minus, yeah?
The fair amount is, minimum, the smallest value of the price is minus $45. How come, right? So is it the driver was driving their mom or something and giving their tips or something like that? So that is definitely something that is odd, right? Anything else, Simon? What doesn't make much sense?
Longitude, negative, again, minimum longitude. In drop-off and then pick-up, it means that I think it is due to mistake, just should be divided by 100. Anyway, there is no attitude like this.
Yeah, it's Mars. It's definitely somewhere on Mars. Yeah, sure. It's definitely doesn't make sense. It's a non-earthal extraterrestrial body that is definitely we can't really reach by taxi, unless you are Elon Musk. So anything else that doesn't make sense?
The same problem with maximum, also latitude, longitude, and this maximum fare could be also outlier.
Yeah, this $500, nah, doesn't look right. Exactly, the highest value of the pickup doesn't seem to be too good. For example, here it doesn't seem to be good either. Anything else?
Passengers count, also minimum 0.
Minimum 0, so they were driving themselves and getting money for that, right? That's nice.
And maximum 200, it means like a train, something like this.
Yeah, I got a little train, and you know, this is what I do for weekends. I drive 200 people on a train as a taxi driver. Yeah, that all makes sense. You guys picked it up, all of it. So that's how the exploratory data analysis works. We see that we have a bunch of weird stuff happening in the data set, which may not be good. This is how we explore the data set. And now we will do some small feature engineering. So the small feature engineering that we will do here will basically take the drop-off longitude and the peak-up longitude, and it will subtract one from the other. So we will find out what was the distance that we travel along the latitude and what's the distance that we travel along the latitude, but in degrees, right? In degrees, not in kilometers, but in degrees. So if you run this next cell, we will get the new features. So if you run train.hat again, we will see that besides the, so this was the way how the old hat looked like. Now, after the passenger count, we will have two new features. This is what's the difference in longitude and latitude between peak up and drop off, right? So what's the difference? So this is a small feature engineering bits that we have here. Let's look at the test set. So we load the test set. We have the same stuff in the test set. We have peak up daytime. We have the only thing that is absent in the test set. What is absent in the test set, Oleg? Comparing to the train.
Fair amount.
Fair amount. So that is not, this is not surprising because this is something that Kaggle competition wants us to predict, right? So this is something that we will be trying to estimate. So we loaded the test set and now we have just defined this function. So this is a function that does some feature engineering on this data frame. So we run the same function on the test set. Because we also, in the test set, we need also this difference in peak up longitude and difference in peak up latitude, right? So that's why we run that stuff. What am I doing here? In this cell, I'm asking myself a question. How many there are null values? Values without any value, right? So what is it? And you remember, Simon, you said that there are 10 people that started a trip but never finished the trip. So here they are. So these are the people that started the trip but never finished the trip. The problem was that their drop-off and latitude and longitude got just dissolved in the data set. So they weren't recorded. That's why there are nulls, right? So in order to drop the nulls, we need a function called drop_NA. So this is something that drops the row, the entire row, if there is at least one NA value. We just drop it. Since we have 1 million records in the data set, we kind of have a luxury of saying, oh, whatever, we don't care. And this is not like half of the data set that has NAs, so we can do it. But it's not always the case that you can do that kind of stuff. Any questions from you guys so far? Igor, where are you?
I am with you on this lecture, and actually I'm on Kaggle to see New York taxi fare prediction.
Did you manage to get this sample submission running here?
Right now, no, but I'm close to that. We'll be in several minutes.
Okay, where are you right now? What is the step that you're doing right now?
Actually, I entered to the Kaggle and found my submissions, and okay. Now I'm editing the script just to get all the stuff done.
Okay, okay. Please do tell us if you have any troubles.
Okay.
We are slowly getting through the exploratory data analysis part.
Yep.
So in the meantime, guys, we will draw the scatter plot of absolute difference on the x-axis and absolute difference in latitude on the y-axis. This is the scatter plot, right? We have drawn only 2,000 rows, not 1 million, but 2,000 rows. And we can clearly see that looking at the absolute difference in longitude and latitude, there are some terrible outliers, right? So there are a couple of observations that are too far away from the main crowd, okay? So what we do here, we're just saying, let's just remove everything that has the absolute difference of more than 5, right? On either latitude or longitude. So let's run that. Let's run that. So we just got rid of like 2,000 rows. Just got rid of 2,000 rows. And now we can plot again the scatter plot, and we will see that, well, now it looks more reasonable, okay? This is now more reasonable. We just cut it off. All the observations that had absolute difference in longitude and latitude more than 5, we just cut them out. We get rid of them. And now we look at the scatter plot again, and we see that basically it's reasonable. It makes sense, right? Good. Any questions about the data set so far, guys? Anything that doesn't make sense, doesn't seem right? Everything is okay? Do you understand what you need to do? So the test set doesn't have the fair amount, so we need to predict fair amount from the trained data and then send the predictions to the Kaggle server. Igor, did you want to ask something? Or was it Oleg who wanted to ask something?
No, nothing from my side.
Okay. Maybe it makes sense again to execute describe method to see.
Yeah, it could make sense to execute the describe. So we go back to describe, we execute the describe. We see that at least the really sad pick up and drop off longitude and latitudes disappeared, which is kind of nice. We definitely didn't get rid of smallest fair amount, the largest fair amounts, largest passenger counts, and that kind of stuff. But at least we got rid of some stuff that is happening with latitude and longitude, right? But there's still room for more pre-processing, right? There is still a way to make this data set cleaner. Yeah, so now my question to you guys, to you, Oleg and Simon. So what do you think is a good and easiest baseline? What's the baseline for this prediction? How can you, what is the most naive way that comes to your mind that you can say, okay, this is the most stupid way to do it, but that's the simplest. What's the simplest and stupidest way of predicting a fair amount for the test data, having your trained data? What's the most stupid way?
You mean not really using regression, just
no, not really using anything. Just the most naive version.
Average.
We know average. Yeah, average of what?
Not longitude. Let's say fair price.
Of
fair
what? So
divided by distance, by travel distance.
Why would you divide by distance?
Per kilometer.
To have fair amount per mile, yeah, per latitude.
Okay, but that's definitely not the most naive. The most naive is what Simon's proposed, right? Just take the average of the entire fair amount column in the training and use it as a prediction for the test for each row. So let's imagine like this. We have, how many do we have actually? How many do we have rows in the test set? Can you guys tell me how many do we have rows in the test set? Use a, I don't know, describe function for the test set. How many rows do we have in the test set?
Wait a moment. It's test DF.
So what's the number of rows in the test DF?
9,914.
Cool. So it's almost 10,000 rows. So for each row, what does each row represent? Oleg, what does each row represent in the test set?
Each row represents one trip by taxi.
Yeah, so we need to predict the price for each row, which means that for each ride, we need to predict a price. So what do I suggest is that we take the entire training data, we find the average price, and then for each row in the test set, we predict this price. That's the most naive baseline you can ever have. Just take the average, and here you go. Can you please make it, code it into this baseline predictions so that there are 9,914 values of average from the training data. You can use a function called np repeat to copy the averages. So this baseline predictions. Go ahead.
But we have already pandas data for this.
Yeah, but let's just say that we need just a vector of 9,914 baseline values. Here I'm making a data frame that we will be using as a submission file. But I need a baseline to be a vector. Igor, where are you? How are you doing?
Just a second.
Getting there?
No. Yeah, I thought my mic is muted.
No.
I'm okay. I'm entering JSON data into the script just to make this submission happens. So everything is fine right now. So no questions. I'm opening this JSON just to enter this information.
Okay. It should have just your username and the key, right?
Yeah. I've downloaded it just right now. I will get it out and make my submission, and will join to you. It will take, I think, up to several minutes.
Okay. Yeah. So let's do it together. So we have a train. What was it? Train, or was it train df? Train, right? Just the train. So I use a fair amount. I can do mean, and then
11.34.
What was it?
11.3.4.
11.3.4. What is that?
It's average fair amount of train.
Okay. I don't know. Maybe that's interesting. So they paid $11 on average. That's pretty cool. Let's see if that. Yeah, 11.34. You're right. But I want to make an array of this 11.34 of size, test set size, right? So if I have test df and then shape, and then the first one, so that should produce, if that would be fine, that it should produce a baseline predictions. If I run shape, it should tell me that it's 9,914 values. Do you guys have similar stuff? Let me copy it to Slack, okay? Here we go. So this is how I create the baseline predictions. I just take a train fair amount mean, right? And then I repeat it as many times as there are rows in the test set. Can you see that? Does it make sense?
Yes.
Okay. And then I'm just seeing that you guys typing something. Are you typing the same stuff?
Yes.
I'm opening my Slack.
You're opening Slack. Okay, cool. Please open the Slack. So what happens right now is that I make a submission file. Here I make a submission file. I create a file that contains 2 columns. One is the test key. This is, I just take the test df.key, and the other one is a fair amount. So I just copied this baseline predictions. So this submission, if I run this cell here, it creates a CSV file called submission baseline.csv. Remember that previously we had a sample submission.csv, and now we have a submission baseline.csv. So sample submission.csv is what has been provided by Kaggle, right? So these are the test predictions provided by Kaggle. These are initial suggestions by Kaggle. And the submission baseline.csv is what we personally have came up with, okay? So this is what we have came up with. Right, and now please, could you send this submission baseline CSV to Kaggle and tell me what's the score? What's the RMSE that we get with the sample submission baseline? Sorry, submission baseline. So complete this line. This is the same line that we have done before to send the sample submission, but now use this line to send the submission baseline. And tell me the score. And what is more interesting is that score is different from what we got using sample submission.
At the moment I have error. Kaggle, the error argument F file is required.
So you didn't really copy the line. So copy the line and change it so that it sends not the sample submission file, but the submission baseline file. So if I go myself here, here's this line that hopefully Igor is right now running. So I copy this line here. I copied, where is that? Yeah, I copied here, right? And what should I change? I should change the name of the file. So I should write submission baseline. And here I should write baseline submission test. All right? Everybody? Simon, have you done it?
Yeah, I'm copying.
Copy, please. I can also copy it to Slack. Igor, where are you?
I have a mistake while getting this my test submission, so I'm trying to figure it out.
Which one? The sample submission?
Just a second. I have error message on mkdir.
Can you share your screen so that we can help you with that?
Share screen? I don't know if I can. Yeah, sure I can. You can start screen share while the other participant is sharing.
I just stopped my screen sharing, sorry.
Just, yeah, copy. Yeah, so I'm here and actually.
No, that's fine. So this is just means that your directory exists. That's okay. Just go ahead and
My name and key is here.
That's fine. Just rerun the cell 19. Okay.
Here.
Yes. And now run the next one.
Oh, wow.
Just run it.
It didn't work. I mean,
plus, you don't need to click yourself. You just need to press Shift Enter. Use Shift Enter, not mouse. You're a programmer now. That doesn't work anymore. Your mouse doesn't work anymore. And now you just put the cursor in the next cell.
Okay.
Okay, gotcha. All right, now run the 22. Mm-hmm.
Well, it didn't work right a minute ago.
I know. I had the same problem, so don't worry about this. Just go ahead and run these cells. Run this time stuff. Okay. You need to rerun the setup. Go up to very top of the file, to the very top.
Like that?
No, all the entire file, the entire file.
Oh.
And then here you have a setup. So rerun the setup. And
I'll
go back to the reading data stuff. Let's just together rerun this stuff. And you guys remember, you need to tell me the score. I didn't hear the score by now.
My score is much better as compared to previous one.
Much better?
Yeah, instead of 9 at the end, it is 8 at the end.
Wait, this is much better. Igor, can you go up? Sorry, where you are right now? Okay, regression. Go a little bit down to the New York City taxi data. Okay, down. Even more. Okay, now read this 28. Rerun it. Okay, now run all these cells until the end. Until we are. Let's see if you just. I really think that it's easier to use the. Hey, try it out, Igor. Try it out. You will thank me afterwards. Put your cursor inside the code. Okay, like this. Press Shift and then Enter. Hit the Enter. Now do the same. Shift Enter. Go ahead. Shift Enter. Shift Enter. Shift Enter. Shift Enter. Shift Enter.
It's black magic, you know.
Yeah, it's absolutely black magic. So now you're a programmer officially.
No.
Just keep on pressing. Keep on pressing. All right. All right. You go. Okay. More. Demand more. Okay. Now the naive baseline. Can you open your Slack?
My Slack is in phone.
Okay. No need for Slack. I will copy it also to chat. Let me see where my chat. Gosh, the thing hidden completely from my site now. Zoom. Okay, now I can see the Zoom window. Where is the chat? Can you guys? Yeah, this was NP repeat. Okay, I can see the chat. God damn, it's so hard. So I just copied to chat. Can you open the chat?
Yep.
Just copy this stuff into this line. Oleg, do you have the same score as we had before?
Yes, almost the same.
So what do you think is happening, guys? Why do we have the same score? Shift Enter. Igor, Shift Enter. There is no way back. You can't go back to clicking. Great. Now submit it.
I like clicking.
No clicking. No clicking. There is no way. Click the Shift Enter here. Cool. Nice. Now I will send another line from Slack to the chat.
Kaggle competition. Submit, yeah.
Yeah, to submit to the Kaggle competition one. Here we go. So it starts with the exclamation mark. Now, please go and check the baseline submission. So what's the baseline submission? Update the page. Yeah, my submissions. And you can update the page. Oh, just click on, yeah, this guy here. Hooray, go down. Go down. All right, so this is what Simeon was saying, that look at these scores. So one of the scores, the baseline score is, I wouldn't even be able to say where the difference is, but there is a difference. It's like one something smaller than that. Simeon, what do you think? Why do we see this difference?
Because we removed outliers.
We removed outliers, exactly. There is another reason. There is another possible reason. Oleg, what is another possible reason? Numeric instability. So this is another possible reason. We were using different
floating,
yeah, different number of floating points after the comma. All right. Whew. Igor, you're now on the same page. Please stick to the same page. Stop your viewing and I can regain the control. Thank you.
Guys.
Now let me please, and remember, never get back to clicking. Only shift enter. Only shift enter. There is no way back for you. I'm sorry for that, but there is no way back.
Yeah.
Let me share my screen. How do I share my? Gosh, I too nervous right now. We are a little bit behind the schedule. All right, so here's my screen. I can share it. Now, finally, great. So what's the main, what do you think, guys? What's the main conclusion? How the baseline submission file, is it, what's the difference with sample submission and baseline submission?
No difference.
There is no difference. It's the same stuff, right? It's the same thing. It's just the sample submission was provided by Kaggle. We have calculated it by ourselves. Cool. Now, the next exercise, the classroom exercise, is to kind of stretch your memory and calculate W1 and intercept for the linear regression. So now we think, okay, let's cut this stuff and let's do the linear regression. So what we will do, we will predict the price from the absolute difference in longitude, okay? So the only variable we are going to use is absolute difference in longitude. Please calculate W1 and intercept for this absolute difference in longitude to predict fair amount. And use yesterday's code. Use the code that we have written yesterday, and the code was here. So this was the code that we have written yesterday. I will just in case copy it to chat so that you guys have it. Here is my chat. Here is my chat. So I just copied to the chat. This is what we have written yesterday. Please reuse this code to make a linear regression on absolute difference in longitude to predict the fair amount for this New York City data set. I'll give you a couple of minutes. Please go for this. as soon as you have it, please raise your hand, okay? The first, as soon as you see that you have it, raise the Zoom hand or physical hand so that I know that you are doing good. Yeah, Igor, in your case, it's only the Zoom hand that you can raise. I'll just copy the stuff that I posted to chat, and then we could you know, change it. Igor, what's the name of the data set that we are working with? So instead of example data, what should we write here?
Oh, sorry, train data set.
Yeah, so the name is just train, right? So instead of example data all over this place, we need just train. It's not the only difference, but it's one of the most important differences, right? Since I asked you, what should we write instead of distance? So yesterday we had a feature named distance, but in this case we need something else. So what is this something else?
Here we have apps different longitude. Apps different.
Yeah, exactly. Longitude, apps difference, longitude. So instead of distance, everywhere we need just to post apps diff longitude. So whatever you see at distance, you just change it to apps diff longitude. Here's the way how I did it. Yeah, do we have to change anything else? Simeon, do we need to change anything else in the old code?
Except the name of the data frame and the distance, I think it is it. At least for me, it works.
Okay. So what did you get? What did you get?
The intercept is 7.3 and the W1 is about 179. Okay,
cool. Oleg, how do you interpret W1? What is the interpretation of this 179.08?
The W1, this is that to travel one longitude, yeah, you need to pay $179.
Yeah, so 1 degree of longitude, you need to pay $179. What is 7.3, Igor? What is 7.3? How do you interpret 7.3? The intercept. How do you interpret the intercept?
Well, just to get a taxi, you need just to pay $7.3.
Yeah, just to get in the car, we need $7.3. Simeon, do you know how many kilometers is 1 degree in longitude? I don't know, but it's a lot.
This is a lot, yes.
I don't know
a bit
myself,
more, a bit more than a lot, I think.
I think, yeah, it's quite huge number, to be honest. So it's seems like about right. So $179, maybe that's the way you need to pay. All right. Now what we will use, what we haven't done last time, we haven't used a linear regression. So ladies and gentlemen, what we have calculated here is a linear regression with one predictor, with one independent variable, that would predict the dependent variable, which is a fair amount. What we do here is using a scikit-learn function called linear regression to do exactly the same stuff, exactly the same stuff, but just much shorter. So you can see it's much shorter than what we had to write. So it's much more efficient and convenient, right? So let's just run this. And we create an object called LR, which surprisingly stands for linear regression. And we use a function called lr.fit to use this first part is a training data. So this is what we use for training, the absolute difference in longitude, and predict fair amount. Here's the predictor. Here's what we predict, sorry, prediction. So we get this linear object now trained. So we can look inside of this linear object. So if we type dir LR, this object inside, we will see all the attributes of these objects, all the attributes of these objects. Could you tell me, looking at these attributes, what are the attributes that contain coefficients like W1 and intercept? Igor, what do you think, which attributes of this list contain coefficients that like W1 and intercept?
I don't know, maybe coef.
Coef underscore, right?
Yeah.
And what about intercept?
Intercept underscore.
Intercept underscore. So there are two things that we care about, the coef underscore and intercept underscore. So here I output them. So you can check them out. So the W1 produced by scikit-learn, by a professional function that is absolutely detrimental for the entire machine learning community, is 179.08, and intercept is 7.31, exactly the same as we have just calculated with this bare hands, right? Bare hands of 1, 2, 3, 4 machine learning enthusiasts and a professional function. But the difference is that we have calculated just 2 values and we didn't need anything else. They got a lot of tons of some stuff, right? That I don't think they actually use for this for these objects. So you can see that you can actually get the same stuff by just knowing exactly how the algorithm works. Now, what happens now is that we predict using this linear, using our calculated coefficients. So what happens is that we take this test data frame, the absolute difference in longitude, we multiply with W1 and we add the intercept. Simeon, what is this happening here? What the hell is happening here?
You're trying to predict the value of the trip.
Yeah, we're trying to predict the value of the fair amount of the trip by using the coefficients of the linear regression. Yeah. So we use the equation of the linear function, which is W1 plus intercept, and we just substitute X into this equation, right? So the X of this equation is the test data frame absolute difference longitude. And we predict the fair amounts here.
But there is a problem. This passenger will pay only if he travels from west to east or from east to west, but not if he travels from south to north, for example.
Yeah, that's absolutely true. That's absolutely true. We kind of discount for people who are traveling the north to south. Wait a sec. Kenneth cannot find the link to today's Zoom. I have to copy the Zoom link. Here we go. So I should join right now. So yeah, what Simon was saying, that we would only care about the people who travel from east to west, or from west to east, but not from south to north. But let's check what the score says, right, in the Kaggle competition, what the score says. The alternative way to predict using the scikit-learn function, which we have been, that we trained, we can use a function predict. So we can type all predict, and then we can use this as data frame, right? So we can just say, take this data frame and produce predictions. So here we are. And now everybody, please submit this to Kaggle. So we generate a new file called submission all 2D. Please tell me what's the new score and what would be the leaderboard standing if we would have this score. So if we would have this score, what is the score, by the way? We will be standing at the position in the table, X. What is this X?
Still loading.
Loading. What is loading?
The statistics from the last submission is just progress.
Okay.
Strange.
I have it.
Internet is so slow.
Simeon, what's the score?
I don't know yet. It is calculating.
Igor, what's the score?
6 point something. I don't
6 point what?
Just a second. 6.07032.
Gotcha. That's the right score. Where would we be? What's the leaderboard position in that with that score?
Right now, I don't know. The leaderboard.
So, so to look at the leaderboard, you have to go here at the leaderboard, and then just find. Yeah, go ahead. What's the position? Did we get to the top? That's the only question that is interesting for me.
No.
We need to get to the top. So, tell me that we are in the top 100.
No.
No. What are you saying? What is the position then? Oh, is it that long to scroll?
Yeah, 1,000.
Oh. Oh, you don't have, don't continue that. That's just so painful. No, no, no. We need to get to the top. This is 1,000 something. That's not good. It's not good. We need to the top 100. Top 100 is the target. Okay, let's get back to the collaboratory. Okay, let's get back to the collaboratory. Let's look at this file that we have created. I don't know why did I want to look at the file, but let's look at the file. Okay, so these files, the submission files, they look as following. They have a key and a fair amount. So these are the headers. And then they have a key, which is basically a date time of the pickup of the test rows. And then there is a prediction, right? So instead of having the same values for every row, we have different values, right? So we have a predictions based on the linear regression. So this is how it looks. Yeah, so we have looked at the RMSE, which is 6.0 something, right? 0.6 or something like this. Now, here is important bit. Before we go on to the small break, what usually happens in machine learning, and you guys, you'll probably use it if you will end up in machine learning community, is we train models and then we save them for a future. We save them for the release people, for the people that work in the company on making the stable versions. So we save the models that we have trained, and then we send them these models. So the way to send the models, we use pickles, right? These are the jars with, you know, this cool vegetables that you can eat in the winter time. So we call them pickles, right? So we take the, so in order to use pickle, we take this LR object that we have created from the linear regression. Here was this object, and we created it here. So this is a linear regression initialized, and then we trained it, and then we predicted on the test set. So if we are happy with this model, we want to save it for a future. And in order to do it, we create a pickle, which is basically just a file type that saves the model weights and all these attributes that we have seen in from the function dir, okay? So if you run this one, and then here, this one, it will tell you, it will show you that there is now a file called linear regression.pickle, right? Now, if I delete this LR object from our namespace, so from the use of this notebook that we are using right now, and we will try to address this LR, it will tell us there is no LR. We don't know what LR is because we just deleted LR. But instead, we can load it from the pickle, right? We can use the standard open file as reading. Oh, okay, run out of input. I don't know what the hell's that. Linear regression pickle, it should be there. That could be some kind of trouble on my side.
I have the same.
You have the same. It could have saved the empty file, so it could have, yeah, that could have been my problem somewhere in this code because it could have saved just an empty file. I'm not sure why this would happen. Yeah, I can't load it right now. Yeah, so the only way I could do is just to go and retrain recreate the LR, is this one here. And then I can try to save it again. Sorry for this. It shouldn't been. Okay, I should have run this line until it says file is not empty. Okay. Now, if I delete LR, it should say, hey, there is no LR, but we're like, oh, but there is LR. Read this LR from the pickle. And now if we go and use LR, it will work, right? So it will find LR. So if we now address LR in the code, it will find LR. Yeah, so this code has some peculiarities. It first saves some kind of empty file, and I haven't really understood what's the reason for that. Maybe there is a better way to save the pickle files. That's the most traditional that I found. But then basically you can delete the LR object and you can read it from the file. So you can send it to somebody else in the company who is dealing with the releases, right? So they will make the final pipelines and you send them the model, and then they take the model and they read it out and they use it to make predictions. Let's make a break for 10 minutes and come back at 10:30, okay? Let's come back at 10:30 and continue with the collaboratory. Today, the plan is to finish this one and start the regularization lecture, okay? So let's have a small break until 10:30. See you in 10 minutes.